What if the universe remembers everything? A new and daring theory is beginning to take shape, one that could completely rewrite the rules of physics as we know them. For centuries, scientists have tried to understand whether the universe behaves like a vast machine that simply follows laws of cause and effect, or whether it is more like a flowing process that constantly renews itself. But what if reality is neither strictly mechanical nor endlessly fleeting? What if the universe itself has memory? Imagine a cosmos where nothing is ever truly lost, where every particle, every vibration, every fleeting thought, and every ripple of energy leaves an imprint that cannot be erased. In such a universe, the past would not simply vanish into oblivion, but would remain encoded in the very fabric of existence, woven into the geometry of space-time itself. This idea challenges the most fundamental assumptions of physics, from the nature of entropy and information loss to the question of whether time itself is an arrow pointing forward or a vast ocean in which every moment continues to exist. If the universe does remember everything, then black holes may not be the ultimate destroyers we once believed them to be, but cosmic vaults where information is preserved in forms we cannot yet decipher. Quantum theory, which already hints at the strange persistence of entanglement and superposition, begins to look less like a world of randomness and more like a system that carefully stores every interaction. Even the expansion of the universe could be reinterpreted, not as a dispersal that forgets, but as a spreading archive in which more and more memories are written into reality. Our own consciousness might then be part of this universal record, meaning that what we think, feel, and experience is not simply ephemeral, but contributes to the ongoing story the cosmos tells about itself. This vision changes everything. It suggests that time may be less about movement from past to future, and more about accessing different layers of memory already present in the universe. The laws of thermodynamics, long seen as the ultimate guardians of decay, might be reframed if the universe is not a place where information vanishes, but where it transforms and remains conserved in hidden ways. Perhaps the mysterious dark matter and dark energy that dominate the cosmos are themselves forms of forgotten but still present information, whispers of ancient states of the universe. If so, the universe is not a cold, indifferent expanse, but a living memory field, endlessly storing and shaping itself. To embrace this possibility is to face a reality far richer and stranger than the one physics has so far described, a reality where nothing is truly lost, and where existence itself is the ultimate memory. The relation between memory and the existent universe is a profound one, because when we speak of memory on the cosmic scale, we are not only talking about human recollection or biological storage of information, but about the very persistence of information in the fabric of reality itself. The universe, in many ways, can be thought of as a grand memory system, one where every process, every particle interaction, and every energetic exchange leaves behind traces that shape what comes next. Just as memory in living beings gives continuity to experience, so too does memory in the universe provide continuity to existence. Without memory, there would be no causality, no time, no stable laws of physics. Everything would dissolve into randomness. But because the universe appears to remember, its states, patterns emerge, matter persists, galaxies form, and consciousness arises. On the most fundamental level, physics already acknowledges this connection. The conservation laws of energy, momentum, charge, and information are themselves a form of memory, ensuring that what happens at one moment leaves consequences that cannot simply vanish in the next. Quantum mechanics deepens this idea through phenomena like entanglement, where particles, once connected, retain a form of shared memory even when separated by vast distances. Likewise, the unresolved paradox of black holes and information loss has led to the radical proposal that the universe never forgets, that even in the heart of a black hole, information is somehow preserved at the boundary of space and time. This aligns with a holographic principle, suggesting that the universe's memory may be written across the very surface of reality. From another perspective, memory is what allows the universe to exist as an evolving system rather than a static one. The past is not erased. It is encoded in the structure of matter, in the fossil light of the cosmic microwave background, in the chemical signatures of stars, and in the genetic material of life. Each layer of existence is a record, a memory of what has been. The universe, therefore, is not merely a container of objects in motion, but a dynamic archive of its own unfolding. Our consciousness, as part of this vast continuum, participates in the same principle. We remember, and through memory we sustain identity, meaning, and purpose. In this way, memory and the existent universe are inseparable. The universe gives rise to memory, and memory, in turn, is what allows the universe to remain coherent, lawful, and meaningful. If the universe truly remembers everything, then existence itself is nothing less than a living archive of all that has ever been, with the present and future continually written upon the indelible page of reality. Thank you for watching.